All right, so looking up here, we have actually more container stuff. We have Mateus. Let me bring Mateus on. So, hello.
Hey guys.
Hey, how's it going? We're going to talk about embedded Linux, .NET GUI applications for embedded Linux using containers. Pretty
Yeah,
awesome.
cool.
Awesome. Well, so I'm going to remove our previous speakers from the stream. Thank you so much. If you want to bring up your screen
yeah.
or your slides, what we're going to share, Mateus, that'd be great.
Let me share.
Excuse me.
Done.
Perfect. Let me bring that up and take it away whenever you're ready.
Okay, so let's start. Thanks. Let's talk about .NET graphical user applications for embedded Linux using containers. It's cool that we have already this talk talking about some specific stuff to minimize and optimize, right? Containers images. That is cool. Who I am Matheus Castello. I'm a Brazilian embedded software developer. I'm working at Turadex. I work with embedded Linux distributions and also development tools for VS Code to make it easier to develop applications for embedded Linux using VS Code today at Turadex, right? I'm also a Linux kernel contributor and also have some contributions on my spare time. I like to contribute to open source projects, right? I already contributed to .NET IoT, to .NET Nano Framework, to Avalonia, and to Uno platform, right? It's Avalonia and .NET Uno platform I will talk about also today, right? But yeah, let's start this subject here, right? I put this slide here because containers is already used, right? Is a very you are very familiar to use containers on web scenarios, let's say web applications and etc. Right? But maybe you are not familiar to run or build containers for embedded device, right? But also for these specific scenarios for embedded devices, embedded applications, containers solves some issues and some problems, right? For example, today on the market, we know that embedded devices are restricted, right? We don't have much storage memory. We don't have much RAM memory, for example. So we have these restrictions. So what the market today does is you need to build yourself your Linux distribution from scratch, right? So you configure and mount everything from the bootloader, the kernel, the root file system, the packages, the libraries, and etc. Right? This to optimize, right, and fit the restrictions that you have on your embedded device, right? But today we already we are seeing the vendors, the hardware vendors, and also some other software vendors that are distributing ready-to-use Linux distributions for embedded devices that are optimized for these embedded devices restrictions, right? But they are optimized to run a container runtime, right? So in this way, you reduce the development time, right? You don't need to develop yourself or your team develop or have something expert to develop a Linux distribution from scratch, right? So you get this ready-to-use Linux distribution, optimize it with a container runtime, and develop and focus the application inside a container, right? Another thing cool about containers are the pattern or the default way that you have to package your application, right? It's a kind of package, right? You have a container image, right? And you can deploy it and run in somewhere that there is this container runtime, right? So it's cool also that we have this layers, right? This system of layers in these container images that you can use to make efficient updates, right? These are some of the points that we have that you maybe can talk about to specific scenario for embedded devices, right? But there is much more, right? let's start here. It's something that I'm delivering here to you. Think about containers for embedded Linux, right? But let's start the subject about the graphical user interfaces with .NET, right? I will present here some of the frameworks that we have that runs on Linux, right? That I already tested on embedded devices, right? And that we have inside the .NET ecosystem, right? Let's start here with a very popular one that is Mono. The Mono implementation of this system Windows Forms, right? There is these implementations for the Windows Forms 1.1 and 2.0, right? And this implementation is a kind of translation, right? For the native calls from X11, right, to WinProc, right? So you can write or call the Windows Forms APIs, and implementation from Mono, you translate this to native calls from the X11 windowing management, right? It's cool to import legacy projects to Linux, right? But I would not recommend to you start a new project today, right? If you have a project, for example, from an embedded compact edition, from Windows Compact Edition, for example, and you are using .NET, for example, and Windows Forms, you can port it for a Linux running to system Windows Forms with Mono. Maybe you need to make some changes, right? Because it's not all that is implemented on the Mono WinForms, right? I put some cons here also. It's CPU bound, right? There is no GPU acceleration. It's not hardware acceleration. There is only the Windows 32 theme, right? The old and good gray theme, right? And no designer for Linux. Well, there is a community effort to have this MWF designer here, but it's a bit buggy, and it's not recommended at all, right? You can use Visual Studio, but as I said, if you use some component that is not supported in Visual Studio, you put the component there because you develop on Visual Studio, you generate the assembly executable, right, and put on Linux, and maybe there is something that will not work, right? Let's go to the demo first. Okay. Let me show here a demo from the Mono WinForms. Let me open it here. It's on my talks. Oh no, Mono. Yeah. So here I have a very simple Windows Forms application, right? Oops. VS Code is. Oh, okay. Let me restart here. Okay. Now, let's see if this will. Okay, yeah, now it's running. I have a very simple form. I can open in the Mono Designer here, the community effort to have a designer that is the MWF designer. You can see I mounted this form on this tool, but it's very buggy. A lot of things does not work. You don't have access to the code. You need to use VS Code Loader editor to code the C#, right? But yeah, this is it. I'll label an image here and a button. Only these components, right? Here, my VS Code is already configured to run to my device. I have here the device. Let me show the target device. Is a Raspberry Pi running Horizon. Horizon is a ready to be used distribution with the container runtime, the Docker container runtime. So I don't need to install everything. It's flash the SD card and it's all there. All the components, all the dependencies to run Docker containers, right? So here on my VS Code, I already have a launch and tasks that you build the application and also you build the container for me. I will show here, for example, the Docker Compose. The Docker Compose is cool to show to you guys. You can see here that I have the service mono who informs the bug. This you also build the container for me, the Docker image for me, right? From my Docker file debug here. Here I have all the dependencies that I need to run. You can see here the mono complete package and everything. I'm getting here from Horizon because, as I said, we have these containers optimized for some hardware, right? And also the vendors are launching some tooling or some containers that are based to you start your development and start in optimized way for run on embedded device, right? So I'm using the base here, the Horizon Extras .NET Uno debug, because I created this one for .NET Uno and has some Wayland bases and X11 base to run, right? So I'm using the same name here, but this one is for mono, right? My bad. It's only to make the demo fast to develop, right? But yeah, you can see that I installed mono complete and other stuff here to open a debug session with the container, right? So I can start here the Horizon ARM v8 debug. Also, these templates are all we launched a VS Code extension that has all the templates for this, so you can create a new project from this. Okay, you can see. Oh, yeah, I'm not showing here the screen. Sorry, here. So you can see here that now on my Raspberry Pi, I have the mono WinForms running, right? It's a window, right? The form one, or label an image from .NET Conf and a button. You can see. I can show to you guys here on VS Code also the Docker extension. I'm using the context here of the Docker extension. I can show to you. I'm using the context here to my board. You can see here the Docker host is pointing to my board, right? So I'm showing here the containers that I have running on my board, right? So I have the mono WinForms that we built it, right? And Weston. And here we have something interesting to talk, because as I'm showing here on this image, the mono WinForms uses X11, right? So we need also to run a graphical compositor with the windowing system, right? So we need these two containers. One container that is the graphical composer and another container that is your application. Okay, you can put all together in one container. Yeah, you can. But you can reuse the graphical composer as I will show on the other demos. For example, I can use the same Weston graphical composer and changing my application here that you use X11 or Wayland, right? So you can also make a tooling, for example, or a base with the graphical composer and your application. And here, the graphical composer comes from Toradex, comes from the developer of the operation system, right? So I don't need to build myself the Weston composer. I'm using it here, right? Another trick, it's this here. You can see that I'm sharing to the containers the host/temp and the host dev and the host run udev, right? These are needed to you have control through input devices to share the Unix sockets, right? The X11, you create Unix sockets for you. So on your application side, you have also the same sharing, right? So you are sharing the same X11 Unix sockets, right? So you can run start X11 window from another container, right? Because you are sharing the composer sockets with the host, and the application container is using it, also sharing or binding the same /dev and /dev for the input device. Okay? Cool. Let's go to the next one. Okay. Avalonia UI. As I say, in 2022 we have more modern solutions for graphical user interfaces with .NET, right? WinForms is very cool. Remembers me from the time from Visual Basic, right? But yeah, it's for our old time. We have another problems today with more modern devices, right? Screens, reactive screens, and etc. So we have another solutions, and one of these more modern solutions is the Avalonia UI, right? Avalonia UI has OpenGL support, so there is harder acceleration, right? They support the frame buffer and DRM. Right, so you can bind or use the /dev from buffer device from Linux, and also the direct rendering mode from Linux, right? This /dev DRI, and has there the cards for your GPU, right? Also, there is a lot of tooling for Avalonia. One of the great tooling is this Avalonia Rider for JetBrains, right, from JetBrains. I already never used it, but it's very cool and runs on Linux, that if I'm not mistaken, right? And there is a great community support. The Avalonia has a very passionate community that maintains the Avalonia project. It's very cool to see the community working on the Avalonia, right? Some cons. It supports only X11. There is no support for Wayland, but you can see here that I put a PR code here. So if you go to the Avalonia GitHub today and search for this pull request, you can see this number, and there is already code to add a Wayland backend. As I say, this is a great community, very passionate community, working day to day to improve the Avalonia framework. There is also no support for VS Code today, but if you search on the GitHub company or this, the project of Avalonia there, you can see the Avalonia VS Code extension repository. That is another community effort to add some VS Code extension for Avalonia, right? And there are plans to add a preview, but I know that there is already XAML code completion for this VS Code extension that is not released yet. It's very alpha version, right? Another con, and here is more, it's a bit of my opinion here, right? Because they use their own XAML dialect, right? It's similar to WPF, but for example, if you search on the internet for documentation and he reuses some code, for example, on Stack Overflow or copy and paste, this will not work, right? You need to make some changes. Some things is very, very similar, the same API, but others not, right? So in my opinion, this it's a bit more difficult to learn if you are learning XAML from scratch, right? Okay, so let's run a demo for Avalonia. Let me disconnect here the mono. Okay, let me open here. Open folder. Let's let's start with the Avalonia for X11. Okay, also a very simple one, right? I can show the example here. You can see that they use also another. Oh, my VS Code is kidding. Oh boy. Okay, let me open again. Because I'm using my extension development host here and it's crashing. But now it's working. It's very simple example. You can see that they use this a example, right? This Avalonia example file here, and you can see that I'm using stack panel. It's very similar, right? Maybe there is some property that is not the same. I don't know. But I'm putting here a test block, an image, and a button, right? In the same way from the mono, we have this template, right? That I will choose here for ARMv8. My Raspberry Pi is running at Horizon 64-bit for Raspberry Pi. And you start the debug session. All the tasks you get my Docker Compose here. You build my Docker Compose file. You can see here the Avalonia test debug. You can see that I'm doing the same thing because I'm using X11 with Avalonia, right? It's the X11 backend, and also it depends on Weston, right? So I need also the graphical composer and the windowing system, right? Okay, it's already running the debug session. Let me see if the window is already there. Not yet. Let's see if the window will show. Here. Okay, so you can see that there is a window in the wing system, right? Because I'm using the X11. I can maximize here. Oh no. Yeah, maximize it, right? Yeah. So I have the two containers. I can show here again. So now I don't have the mono, but now I have the Avalonia test, right? And also the Weston, the same Weston that I'm sharing the /dev and /temp with the Unix sockets, right? Also, I have the debug session here. The Docker file, I have two Docker files, right? One for production, that is very optimized, right? And one for debug, because for debug, I can start our OpenSSH server, right? And attach my VS Code debugger, right? For example, I have here a breakpoint for the button, right? So if I press the button here, let's see, my time is ending. Yeah, so if I press the button here, you can see that's running on device, but I'm getting the breakpoint here on my machine, right? It's connected through the debugger, the VS debugger, right? On the target. It's very cool, right? And yeah, now it's changed here the level. Cool, right? The test block, right? It's not Windows Forms anymore. It's Avalonia, right? Okay, but also, as I said, we have, let me open here, the DRM and frame buffer. Avalonia has this support. And it's cool because for embedded devices, as we have these restrictions for memory and storage, maybe you can run it in a more restricted device that don't need the Weston composer. This will need only the Avalonia application, because the Avalonia application will know how to draw the components and everything on the frame buffer directly, right? Or on the GPU device, right? For example, here my Docker Compose, you can see for this one is for Avalonia using the directory render mode and from a buffer. You can see here that instead I'm sharing only the temp and dev, I'm also sharing the run dev, right? Because now the binds for input devices and the management of the input devices will be done directly from Avalonia side, right? Also, the people that are talking about containers before me, they talk about rootless, right? All the containers here runs rootless, and I, instead of run this as privileged, right? I can only list here the devices, the cgroup rules for the devices that I want, right? So you can see here that I'm passing cgroup rules for /dev DRI and for /dev from a buffer 0, right? And you can see that there is no Weston, right? There is no Weston device. There is no dependence on Weston anymore, right? Because I don't need a compositor. The application you draw directly on the frame buffer for me. This changes a bit the main program, right? The template here for Avalonia DRM from buffer has these two calls, right? You can use these two calls, or you can choose. Here I'm using the environment variable to choose between the two, and here on my launch JSON, I can choose. For example, here I'm using the frame buffer, right? So for this demo, we run the start Linux frame buffer def, and this will draw to frame buffer 0, right? My time is very short. Let me start here. Yeah. My time is very short. Is there's the Uno yet? The Uno demo yet? So now it's very lightweight now because I don't need the compositor, right? I need only the Avalonia application. I will show on the containers running. Let me show here. You can see there is no more Weston, right, running. Only the Avalonia DRM FB service, right? But it's starting yet. Let's see. Oh, okay. I put a breakpoint here to you see that I set the variable for Avalonia from buffer. Let's continue, and this will get or/dev from buffer 0, and we'll draw on the from buffer for us. And my time is ending. Oh. Go. Yeah, there is it. Okay. It's the same code, front code behind here. I have the same. I can get the breakpoint here. I can press here. Now it's not the Weston, it's not the windowing system that is handling the inputs, right? My touch panel here is an input, right? You can see that it's all Avalonia, only Avalonia that's handling using the libres, right? From Linux to do it, right? Yeah, it's working, right? Okay, let's go to the last one. As I said, only one container, only the container for Avalonia, right? Uno platform to finalize here. My time is ending. Okay, with the Uno platform is my preferred framework today for graphical user interfaces to use with Linux, right? There is also OpenGL support. There is framework support. They don't support the DRM, the direct render mode. I don't show with Avalonia that you don't have time, but you can get the templates from the Visual Studio Code extension from Toradex, right? Also, there is a cool VS Code extension from Uno platform. They has the XAML code completion and also the hot reload server, right? I will show already the demo because I think the demo is more important than I will talk, and my time is ending. Let me go to the Uno platform here. Yeah, this one. Let's use the Uno platform frame buffer. There is also the Uno platform with GTK, so they will use GTK sharp behind scenes. There is a driver for GTK using TGTK sharp, but there is the same problem, right? You had to run the Weston, right? To run the on the platform with GTK, you need the windowing system, right? I will run here this one that is the same. There is using the from buffer calls. Where is? Yeah, here. You can see that for on the platform is very automatic. You don't need to specify the device, the /dev device from the frame buffer. But also don't know how they handle multiple frame buffers, right? I'm tested only with one frame buffer, right? Okay, let's run this one because I want to show the hot reload. I don't know if I will have time. But let me see. Okay, building it. So the task here, the template here has all the tasks to build your Docker Compose. You can see that there is more or less the same, right? /dev, /temp, /dev, /run udev for the input devices, right? The C groups is rootless, right? The C groups for the permission for devices, right? And no Weston. You can see there is no Weston. Here, the Uno platform using Skia is drawing directly to the frame buffer. Okay, let's see. Okay, there is our application. What I want to show here, guys, is the hot reload. That's very cool. For example, I have the test block here, right? And I can change it here. For example, let me put my name here. And I save. Oh, and it's not working. Oh, yeah, of course. But it's okay. Let's go ahead and finish here the presentation. I already talked about the GTK sharp, and I want to only to shout out here some of the older graphical users interface that we have. That is the KML.NET. This is very important, but it's not maintained anymore. So I'm looking forward to someone from the community to get it and get a fork and continue to work, right? Because it's very important for embedded devices have on the .NET ecosystem something to work with Qt, because Qt is very important. It's a very strong player on the embedded device. There is Ito that I have not tested, but there is a lot of tooling that's cool. And Maui for Linux, that is a port from community. We already have something running with the GTK sharp driver, with GTK sharp backend, right? Yeah, thank you. My time ended, right?
Yes, it has. We're a little bit over time, so if you want to look at the comments for questions, that would be great.
Okay.
Because we have Shay and we have Arthur, and we need to kind of get going with them.
Okay. Sorry about it.
No worries. Oh, good. Hey, it was great. It was awesome. I love that. You were in the zone. It was really, really interesting, and I appreciate you sharing your passion and all these great demos with us.
Thank you. Thank you.
Thank you so much.